This is Mrs. Dawson. Graph each function. State the domain and range. A. f of x equals 3 over x minus 2 plus 4. B. f of x equals negative 2 over x plus 3 minus 2. Let's begin with A. The function is 3 divided by x minus 2 plus 4. In both of these examples, you'll notice that we have a pattern, and we'll be using some variables where the number in the numerator is a, and then we'll use x minus h as the denominator, plus k. And that will just be our general form of this type of function. To begin with, each one of these represents a transformation of the parent function 1 over x. Let's take a look at 1 over x. And we'll look at a standard window. So you can see the graph of 1 over x. Investigating each one of these numbers, we'll see what happens. So in this example, a is equal to 3. So let's graph 3 over x and compare it to 1 over x. And moving to the right, to the left, we'll make this bold by hitting enter. So you can see 1 over x and then 3 over x. So by a being equal to 3, the graph is expanded. Now let's look at the x minus 2. In other words, h is equal to 2. Three divided by, you'll need parentheses for the denominator, x minus 2. Scrolling to the left, we'll make this one bold, and the one previous just normal. So once again, you can see the original 3 over x, and now 3 over x minus 2. And you can see that asymptote which showed up. Obviously you know that that line, that vertical line, is not there. It's just a feature of the calculator. So f of x equals 3 divided by x minus 2, translated the graph 2 units to the right. The next value will be the k. K is equal to 4. So now we have the function which was given, f of x equals 3 divided by x minus 2 plus 4. So we'll take y3 and make it normal. And then enter the function given in part A as y4. That is 3 divided by the quantity of x minus 2 plus 4. And we want to make that bold. Graph, you can see 1 over x, then 3 over x, then 3 over x minus 2, and last but not least, 3 over x minus 2 plus 4. Notice what happened. We expanded from having the 3 as the numerator. we shifted 2 units to the right as having x minus 2 as the denominator, and then by adding 4, the entire function shifted up 4. The other thing we'll want to do for part A is to state the domain and the range. Notice that we're dividing by x minus 2. Because we cannot divide by 0, x minus 2 cannot be equal to 0, which means 2 is not in the domain. So our domain of part A would be all values of x such that x is not equal to 2. For the range, notice that because 3 over x minus 2 cannot be equal to 0, then the entire function cannot be equal to 4. So the range would be all values of f of x such that f of x does not equal 4. To go along with that, if we look at the final graph, you can see that we have a horizontal asymptote at 4 and a vertical asymptote at 2. So the domain does not include the value of 2 and the range does not include the value of 4. Part B. Very similarly, we'll begin with 1 over x, and then we can change the 3 to a negative 2, and we'll be dividing by x. You can insert instead of typing over. I'm going to change that to negative 2. This time we're dividing by x plus 3. And then subtracting 2. So the final function will be negative 2 divided by x plus 3 minus 2. Part B, f of x equals negative 2 divided by x plus 3 minus 2. Comparing that to the function from Part A, where we had the numerator as a, the denominator x minus h, and then the constant at the end plus k, we can identify that a is equal to negative 2, and that is going to expand for us, and we'll investigate the graph shortly. Because of the negative, we'll also have a reflection. The h value, in this case, is negative 3, which means we'll translate 3 units to the left, and the k value is negative 2, which means we have a translation of 2 units, but because of the negative, it will be 2 units down. The domain we'll identify by noting that x plus 3 cannot be equal to 0, which means x cannot be negative 3. The domain for this function will be all values of x such that x is not equal to negative 3. And then the range because negative 2 divided by x plus 3 can never be equal to 0, then negative 2 divided by x plus 3 minus 2 can never be equal to negative 2. So the range will be all values of the function such that the function, or f of x, is not equal to negative 2. So let's investigate the graph. In y1, we have the parent function 1 over x. And for now, I'm just going to turn off the other 3. So we'll graph the parent function, and you can see 1 over x. Going back to y equals, we'll turn on negative 2 divided by x. We're expecting an expansion and a reflection. And let's make that bold so it's easier to see. So we expanded and reflected over the x-axis. Putting y2 back to normal by hitting enter. So you're back to the original, and then y3 we'll put bold and turn it on. The x plus 3 in the denominator, we're expecting a shift or translation of 3 units to the left. So you can see 1 over x, negative 2 over x, and now we've shifted 3 units to the left, and we have negative 2 divided by x plus 3. We'll make that one normal. And then y4, which is the final function listed in part B, turn that on. Negative 2 divided by x plus 3 minus 2. So we're expecting to see what we had in y3, only this time shifted 2 units down. There's 1 over x, negative 2 over x, negative 2 over x plus 3, and last but not least, our final function of negative 2 over x plus 3 minus 2, where we have a horizontal asymptote at negative 2 and a vertical asymptote at negative 3, which supports our domain and range.